Hello and welcome to helpyourmath.com. In this video, we are going to look at the cardinality of intersections and unions of two or more sets. Before we get into the examples, let's just go over some of the terms. The cardinal number or cardinality of a set is the number of elements that are in that set. For the notation, we use n of a, so this is pronounced n of a. And this just means the number of elements that are in set A. So for example, if set A consisted of the elements 1, 2, and 5, then the cardinality or cardinal number of set A, n of A, is equal to 3. The intersection of two sets is the set of elements that are in both sets. We use the notation A intersect B to represent the intersection of sets A and B. So if set A contained 1, 2, and 5, and set B contained 3, 4, 5, then we would say A intersect B is 5, the set containing the element 5. The cardinality of the intersection is 1 because there is one element in the intersection. The union of two sets is the set of elements that are found in either of the given sets, or if it's in both sets, that's okay too. For the notation, we say A union B, so it's called union, A union B, to represent the union of sets A and B. If we look at those sets A and B, A union B would be 1, 2, 3, 4, 5, because those are all of the elements that are either found in set A or set B or both, and we would say that the cardinal number of the union is 5 because there are 5 elements in the union of the two sets. Okay, so now we're going to be given the cardinal number of each region, and we're going to use that to answer the following question. So note that this is not the elements, this is the cardinality of each region. First, we want to figure out what is the cardinality of A. What's the cardinal number of A? Well, A is this set here. So what's in this set here? Okay, so set A has 5 elements here and 3 here. So the cardinality would be 5 plus 3. The cardinal number for set A is 8. Looking at set B we have this here. In set B, we have 3 elements here and 8 here, so 3 plus 8. The cardinal number of set B is 11. When we look at the intersection of the sets, we are looking for what they have in common. So this is the region right here where A and B overlap, indicating to us the cardinal number of the intersection is 3. And last but not least, we want the cardinal number of the union. That would be anything found in either set. So we're looking at all of the regions that would be contained in here. So we want to add together 5 plus 3 plus 8. 5 plus 3 is 8. 8 plus 8 is 16. So the cardinal number of the union of sets A and B is 16. Let's look at one more example where we've added a third set into our universe. We now have a set C as well. First, we're going to start by identifying the cardinal number of each of the individual sets, and then we'll look at the unions and intersections from there. I always encourage you pause the video, see how you do. Starting with set A, so again, set A is going to be anything contained in here, and remember, these are the cardinal numbers for each region. So we want to add together these 4 numbers, and that's going to tell us the cardinal number for set A. So we have 4 plus 1 plus 7 plus 3. Well, 7 plus 3 is 10. 4 plus 1 is 5. 10 plus 5 is 15. So there must be 15 elements in set A. Set B is going to be anything in here. So we have 4 regions in set B. And we want it, let's see, we have 1 plus 9 is 10. 3 plus 3 is 6. So set B has a cardinality of 16 that indicates that there are 16 elements in set B. Set C is down here. And we have 4 regions found within set C. We have 7, 3, 3, and 11. We want to add those together because remember, these are the cardinal numbers of each region. 7 plus 3 is 10. 3 plus 11 is 14. 10 plus 14 is 24. There are 24 elements in set C. So that was just identifying the cardinal number of each set. Now what about the union and intersection of each? And actually, I'm going to add on to this. I'm going to put one more down here. We're going to look at A intersect B intersect C. Actually, I'm going to add 2 more, and then A union B and union C. But we're going to start with the ones up here first. So first, we want to look at A intersect B. So remember what region we're talking about with A intersect B. Where does A intersect B? Right in here. This whole region here is where A and B intersect. You'll notice that there are two different regions within the region of A intersect B, right? There's the one here and there's the 3 here. So we want to add those numbers together to get the cardinal number of the intersection of A and B. That would be 1 plus 3, and it would be 4. We want to be really careful with that. It's the entire intersection, so it's where the yellow overlaps the green. Next, we're looking for the union of A and B. Okay, so the union of A and B, that's going to be anything found in either set A or set B. So that's going to be here and here, and we want to add up all of these different regions. When we add, we have 4 plus 1 plus 9. So I'm going to go ahead and write these down. 4 plus 1 plus 9 plus 7 plus 3 plus 3. And we want to combine all of these. I see one 10 here, another 10 here. So we have 10, 20, it looks like 27 is the cardinal number. Now, given that we're adding 6 different regions, it's very likely that we might make a mistake. Is there a better way that we can do this? Well, maybe not a better way, but there is a different and shorter way. If we knew the union of all 3 sets, so if we figured this out first, then we could just subtract the regions that aren't included. So maybe we want to figure this out first, and then we can use that to help us, and we can verify that we do end up with 27 going the other way. So this is the union of anything that's in either set A or set B or set C. That means we want to add together all of these regions. We don't have our outer rectangle this time, so anything that we see, any number we see, is included in the union. So when we add all of these up, we have 4 plus 1 plus 9, 7, 3, 3, and 11. When I add these all together, I'm going to look for my 10s. I have 10, 20, oh, this is 31, and then 31 plus 7 is 38. So there are 38 elements in this entire universe here. And so now if we work backwards and we said, okay, we know that there's a total of 38 in here. And if here we're looking for A union B, we want to subtract away the 11. So 38 minus 11 gets us back to 27. Does that make sense? We'll try it again, don't worry. First, we're going to look at A intersect C. And before I look at A intersect C, since it is kind of getting crowded here, I'm going to go ahead and erase all the highlighting, and we'll start fresh with A intersect C. Okay, some of it came back, but that's okay. So A intersect C. So where does set A and C overlap? It looks like they overlap here and here. So we have these 2 regions where A and C intersect. So we're going to add these together. 7 plus 3, A intersect C is 10. How about A union C? So what's contained in either set A or set C or both? Remember the shortcut we could take? So we could either say, okay, A union C is going to account for this whole thing here and then here. It's like almost like an 8. What region is not included? That would be this 9 over here. So what we could do is we could just do 38 minus 9, indicating to me that the union should be 29. If you're still not totally comfortable using that, that's fine. We can add up all of these numbers. So this would be, let's see, 4 plus 1. I'm looking for anything contained in the orange, plus 7 plus 3 plus another 3 plus 11, right? 4, 1, 7, 3, 3, 11. Here I have a 10, here I have 14, and here I have 5. So this would be 15 plus 14 is 29. The system works. So we have A union C is 29. Again, I'm going to erase just because it's a little bit sloppy here. Okay, so now for the next 2, we have B intersect C. So where do B and C overlap? Right in here, right? These are where we see they're contained in set B. They're also contained in set C. So if we add those 2 regions together, we're going to see that the number of elements in the intersection of B and C is 6. How about the union? Well, the union here would be anything in C and B. There's my little weird 8. And do you remember the shortcut we could take? So we can either say, okay, I know that the union is going to contain all the elements in here, which is all of the elements in this diagram except for these 4. So we could do 38 minus 4 and get 34. If we wanted to check our work or add up all of the regions within the purple, that's fine too. That would be 1 plus 9, right? 1 plus 9 plus 7 plus 3 plus 3, 7, 3, 3, plus 11. When I add these together, here's a 10, here's a 10, here's a 14. That would be 34. So the union is 34. The system works. Last one. What's the intersection of sets A, B, and C? So we're looking for where do all of those sets overlap? Well, where do we see A overlapping B and overlapping C? That would be in this kind of weird triangular region here, indicating to us the cardinal number of the triple overlap is 3. So there we have it, the cardinality of the individual sets, of the unions of the sets, and the intersections of the sets. Thank you for stopping by.